Good morning. In our previous session, we have discussed about methanol oxygen fuel cells. So in methanol oxygen fuel cells, we have methanol as the reactant or oxidant and oxygen at the cathodic site. The electrolyte used here was the sulfuric acid, right? Here, the construction part is as same as our methanol oxygen fuel cell. The only thing which differs here is the electrolyte. In solid oxide fuel cell, the electrolyte used is solid. So the yttria doped zirconia is the electrolyte. The electrolyte used here is the yttria doped in zirconia. So let us see the electrochemical reactions occurring anode cathode used, advantages, limitations and applications of solid oxide fuel cell. It is called as solid oxide fuel cell mainly because the electrolyte used here is solid oxide. That is the reason it is called as solid oxide fuel cell. Here hydrogen is used as one of the reactant and oxygen is also used as one of the reactant. The fuel is hydrogen and air, oxygen is used at cathode. The water is formed as a product. Let us see the anode cathode electrolyte used. Anode is porous cermet made of nickel, metal of yttria doped with zirconia, whereas cathode is also strontium doped with lanthanum magnetite. As discussed earlier, electrolyte is solid state of yttria doped with zirconia. Since the electrolyte used is in solid state, it is called as solid oxide fuel cell. The electrochemical reactions which occur in solid oxide fuel cell are: at anode, oxidation of hydrogen. So hydrogen in presence of O2 minus undergoes oxidation to give water, whereas oxygen, which is the reactant at cathode, undergoes reduction accepting the electrons liberated at anode to give O2 minus. The net reaction is H2 plus O2 giving water. The water is once again non-toxic and eco-friendly. Here, whether it is methanol oxygen fuel cell or solid oxide fuel cell, the fuel cell is a reaction site itself. Hydrogen and oxygen both are once again saved. They are stored at high pressure separately. So the product is continuously withdrawn from the cathode anodic site and it is removed continuously until hydrogen and oxygen are supplied continuously. We can withdraw the power or energy. Once we stop either one of them, no more energy is withdrawn. The advantages of solid oxide fuel cells are: the efficiency is normally 60%. The heat is utilized such that the efficiency will increase. The solid oxide fuel cell is utilized in tubular form, whereas such that the output is 100 kilowatt of electricity. The advantages of limitations. Some of the advantages of solid oxide fuel cells are: it is able to use natural gas as fuel with minimal or non-pre-processing. So since natural gas itself can be used as a fuel, so the processing is not at all required. Uses hard ceramic material as the electrolyte. So sulfuric acid is using in methanol oxygen fuel cell. It is corrosive. Since it is in solid state here, so matter of corrosion does not come itself. So no platinum catalyst. The operating temperature is also high. It operates as 980 degrees Celsius to 1800 degree Fahrenheit. So good quality of waste heat. So potentially very low manufacturing cost because cheap materials for fuel cell stack. Even this is also having some of the limitations. What are those limitations? So slow startup and load following. High temperature balance of plant materials are required. So these are some of the limitations of solid oxide fuel cells. So the applications, it can be adopted from small portable, very small portable like watches, to military applications to large megawatt class stationary applications. Solid oxide fuel cells are flexible unlike the methanol oxygen fuel cells, which makes them preferred technology for installation with the existing infrastructure such as gas pipelines. Solid oxide fuel cells demonstrate more electrical efficiency than any other type of fuel cells. Solid oxide fuel cells most preferred fuel cells due to their high power to area. Tubular fuel cells, as already discussed, follow planar in terms of market share. These are more stable for long terms than other, but lack in power to area ratio. So let us see the diagrammatic representation of the applications. So whatever waste, whether it is animal waste, whether it is factory waste, kitchen waste, agriculture waste, poultry waste, so whatever it is, finally we get some biogas. So the fuel cell, the solid oxide fuel cell, it requires mainly gas, the hydrogen gas, right? So the gas obtained, we get biogas. That gas can be fed into the anode. At cathode, once again, it is a oxygen. So here what will happen? Redox reactions occur. From redox reactions, energy will be liberated in the form of heat, right? So that heat can be used to run heat turbines. From heat turbines, electricity can be generated. So whatever energy is liberated from there, once again it can be used for transportation. Fuel cells are used in transportation, portable devices like laptops. It is also used in stationary applications. It is used in homes, it is used in ships, etc. So these are the various applications of solid oxide fuel cells. Thank you.